There's this piece of technology that's so fundamental to our lives, you probably used its energy this morning without even thinking about it. We're talking about steam boilers, the quiet, powerful, hidden engines of our entire modern world.
So let's just jump right in with a big question. How in the world do you power an entire city with something as simple as water? Well, the secret is turning that water into something way, way more powerful, high-pressure steam. And the machine that pulls off that magic trick, that's the steam boiler.
So what is it exactly? At its heart, a steam boiler is basically a super strong sealed container. You heat water inside it, and it creates steam under insane amounts of pressure. Honestly, the best way to think about it is like a super-powered, industrial-sized pressure cooker, but instead of making dinner, it's making the power that runs everything from factories to the electrical grid.
Now, you can't just build any old giant kettle and call it a day. Oh no. Engineers have a very specific vision when they design a boiler. They're basically chasing this dream of a perfect machine, one that has to meet a whole laundry list of really tough demands. And here's that wish list. You want the most steam possible for the least amount of fuel. Total efficiency. You also want it to be simple to build, cheap, and fire up really fast. And of course, it absolutely has to be incredibly strong, totally safe, and easy to fix. But here's the catch. You can't have it all. These things often fight against each other, which forces engineers to make a really big decision right from the get-go.
And that decision brings us to this huge fork in the road in boiler design. It's a single choice that splits pretty much all boilers into two totally different families. And it all boils down to one very simple question. Where does the fire go? Do you run all the super hot gases through a bunch of tubes that are sitting in water? Or do you do the opposite and run the water through tubes that are surrounded by the fire? It sounds like a small detail, right? But that one decision changes literally everything about how the boiler works, what it costs, and how safe it is. And this right here shows you exactly what I'm talking about. On the left, you've got the fire in the tubes approach. See how those hot gases snake through pipes that are completely submerged in water? Now look at the right. It's the total opposite. The water is inside the tubes, and the fire is raging on the outside. Okay, so you gotta lock in these two names. They're the key to everything. When the fire is in the tubes, we call it a fire tube boiler. And when the water is in the tubes, it's a water tube boiler. Simple as that. This one distinction is what we're gonna unpack. All right, so what does this all mean in the real world? What are the actual consequences of that one design choice? Let's put these two boiler types head to head and see how they really compare. First up, let's talk about cost and just how simple they are. The fire tube boiler, because it's basically a big tank with pipes in it, is way simpler and more rigid in its construction. That makes it cheaper to build, which is awesome for smaller businesses. But all that water in the tank takes forever to heat up. The water tube boiler, on the other hand, is more complex, so it costs more upfront. But because there's much less water in the system at any one time, it can get up to pressure way, way faster. Now, what about raw power and size? Well, that big shell on a fire tube boiler just can't handle super high pressures, so its power is limited. But that giant reservoir of hot water is a huge advantage. It means it can handle sudden demands for steam like a champ. Think about a factory where machines are turning on and off all the time. But the water tube boiler, that's the undisputed king of scale. It's built for unbelievably high pressures, for the gigawatt-scale power plants that form the backbone of our entire electrical grid. And then we have to talk about safety. This is a big one. A fire tube boiler holds a massive volume of explosive, high-pressure water in one single container. If that shelf fails, you're talking about a catastrophic explosion. A water tube boiler, though, it's smarter. It spreads that high-pressure water out across hundreds of smaller, stronger